Hey Jada,
Hi, Mr. Strong.
I guess it's just gonna be you and me today.
Okay.
So, did you get a chance to work on that problem?
Oh, no.
All right. Well, why don't you take a minute and see how far you can get on it, and then we'll go over that. Achoo!
Okay, so I'm trying to get the outflow rate and the inflow rate, but
Okay.
I'm stuck.
All right. And let me. Okay, so there's actually the notes I said I would come back to. They were like, let's see, where's the. Okay. Okay. So at the beginning of the section, there's these three things: rate out, rate in, and rate of change. So you might just write that down for just a minute. Let's see, this is actually times. And then we'll go over that. All right, so let's go through it then. Oops.
Oh, Mr. Strong, your camera's pointed at your desk.
Oh, okay. Thanks. Yeah, I forget to change that a lot. Okay. Okay. All right, so it says the tank initially contains 100 gallons of brine in which 50 pounds of salt are dissolved. So instead of gas, like we had yesterday, gasoline, we have brine. And then instead of the additive, we're putting salt in it. Okay? A brine containing 2 pounds per gallon of salt runs into the tank at a rate of 5 gallons per minute. The mixture is kept uniform by stirring and flows out of the tank at a rate of 4 gallons per minute. So it says at what rate in pounds per minute does the salt enter the tank at time t? All right. So it says it comes in at 2 pounds per gallon at the rate of 5 gallons per minute. So if you multiply those together, the gallons will cancel. So you'd have 2 pounds per gallon times 5 gallons per minute. The gallons will cancel, and so you'll get 10 pounds per minute.
Okay, I got that.
Okay, good. All right. So then the next one, what is the volume of the brine in the tank at any time t? Okay. So did you get that one?
No,
Okay.
just did A.
So you say, well, what you start with 100. You start with 100 pounds of the stuff, and then you're pumping it in at the rate of 5 gallons per minute, and then you're pumping it out at the rate of 4 gallons per minute. So it's 100 plus 5t minus 4t, and then when you simplify that, it's 100 plus t. So that's the volume of the brine, not the salt. I misspoke earlier. So at what rate in pounds per minute does the salt leave the tank at time t? Okay, so this is going to be our equation. Okay. So the rate out is the y of t. So in this case, it's just y over v of t, which we just did, 100 plus t, times the outflow rate, which was 4. So it's going to be y over 100 plus t times 4. Okay? So any questions on that?
No, I'm good.
Okay. So now it says write down the initial value problem describing the mixing process. Okay? So that's where we do the inflow minus the outflow. So the change in the brine, dy dt over time, is the rate in minus the rate out. So we just take those two answers that we just got, and it's going to be dy dt equals 10 minus 4y over 100 plus t. Now the initial value, it says that when time starts, or before we started, we have 50 pounds of brine in there, so of salt. So y sub 0 is equal to 50. So that's our initial condition that's going to help us find C. Okay, so now, do you remember, well, see if you can put this as this differential equation in standard form. So see if you can write this as the differential equation in standard form. Okay. All right. So did you get that?
Yeah.
So you have the dy dt plus the function with the y in it equals the function without the y in it.
Okay, yeah. I the first time I did it, I tried to get the y by itself, but I redid it.
Yeah,
Like
you
that.
don't. So what we're gonna do? Okay, so now, okay, so what is the p of x, or well, p of t in this one?
For
Yep,
400 plus
4
t.
over 100 plus t. What's the q of t?
10.
Just 10. All right, and then you have to find the v of t. So what would we do to calculate the v of t?
The e to the integral of pt and qt.
Of just p of t.
Or p. Oh yeah.
So it's just the integral of e raised to the integral of 4 over 100 plus t. Okay. All right. So now, what would this integral be?
Could you bring anything out in front, or do you have to just leave it?
You can bring the 4 out front.
Okay.
You bring the 4 out in front, and then, so what would the integral of dt over 100 plus t be? If you have the integral of du over u, what's that?
Would be u squared.
No, no, because it's not u to the first. See, it's du over u. The u is in the bottom. So the integral of du over u, that's equal to the natural log. Whoops. That's the natural log of the absolute value of u. Plus c. So for this one, if we bring the 4 in front, see the derivative of 100 plus t is just 1. So we get, so dt over 100 plus t, that's going to be the natural log of 100 plus t. All right. Now, if we want to put this in a different order so that the e is next to the ln, and so then the 100 plus t comes down, so you get 100 plus t to the 4th power. Now, I can drop the absolute values here because, see, remember, t is time. And so t is not going to be negative. So 100 plus t has to be positive. So you can drop the absolute value and just put 100 plus t in parentheses to the 4th. Okay. So then what is it that we're going to solve then? What's y equal to?
You do the 1 over v of x.
Yep. So it's going to be 1 over
Times the integral.
Times the integral of
v or vx cubed t and pt.
Yes. So 1 over this v of x, so 100 plus t to the 4th, times the integral of 100 plus t to the 4th. So the v of x times q of x times 10, and then dx. Okay, so now this integral, if you bring the 10 in front, and then what would be the integral of 100 plus t to the 4th? What's the integral of blob to the 4th?
Three. Is it 3?
No. What's the integral of x to the 4th?
X cubed over 3.
No, you're taking the derivative. With the integral, you add 1 to the exponent,
Oh, x.
and then divide by that new exponent. So it's going to be 100 plus t to the 5th divided by 5 plus c. And then the 10 I brought in front. All right. So now it's just some algebra here to simplify this mess. Okay. So I start with the 10. When I distribute the 10 through, it's going to cancel with the 5 here, leaving me with 2 times 100 plus t to the 5th plus 10c. All right, now I distribute this through 100 plus t to the 4th in the denominator, and see that's going to cancel with 100 plus t to the 5th, leaving me with just one of them. So I get 2 times 100 plus t plus, and then when I distribute this through, 10c over 100 plus t to the 4th. Okay, so now that's the general solution. So now what I have to do is use the initial condition that the y of 0 is 50 to figure out what c is. Okay, so if I plug in 0 for t and plug in 50 for y, then I can solve that for t. I mean for c, excuse me. I'm plugging in 0 for t. So I get 50 equals 2 times 100 plus 10c over 100 to the fourth. So to solve that for c, I'm going to multiply this out and then subtract. So I get negative 150. And now to solve this for c, here let's go ahead and throw in an extra step here. Well, no, never mind. So to solve for c, I multiply by this reciprocal. So then I have 100 to the fourth over 10. And so now we just put that in the calculator, and we got c equals negative 1,500,000,000. All right, so now in place of c, I put that number into the general solution. I plug in c, and then I went ahead and multiplied this out, this 100 to the fourth, so that then I could simplify that. And so it ends up being just simplifying down to minus 15. And so now I can go ahead and simplify and combine like terms, and I get y equals 2t plus 185. Okay, so now with this, I could tell how much salt is in there at any given time. Okay, so let's say after 20 minutes, how much salt would be in there in the mixture after 20 minutes, or after, well, let's say 10 minutes. What would I plug in 10? Where would I plug in the 10?
The t.
In the t. So 2 times 10 would be 20. So 20 plus 185 would be
205.
205. So after 10 minutes, there would be 205 pounds of salt in that big mixture. Okay? So once we have it to this point, whatever t is, it tells us exactly how much salt is in the mix. Okay? Now, the thing is that, when in business and industry, that's what engineers do. That any kind of fluid situation, they will figure stuff out, because you don't want to, if you keep saying, well, if the boss says, well, how much salt is in there? Do we need to add more salt? And you don't know, well, you could ruin the whole batch. And so probably in days gone past, people would just estimate. But now, see, you can use the calculus to figure out exactly. And so if you're trying to create the solution, whether it's with gasoline at a refinery or with this at a preservation or canning place, you can calculate exactly how much is there. Okay. All right. So any questions on that? Well, that was a long old practice problem. So did you have any questions on that, Jada?
No.
Okay. Well, I think what we're going to do, because we have 2/3 of our class gone, Weston's sick and Tobias is at a baseball game. I kind of don't want to cover anything new. I wanted to go over that because we kind of went over it yesterday. But I think I'm going to go ahead and call it a little early today, if that's all right with you. And then we'll just start tomorrow with 9.4. Okay?
Okay.
All right. Well, thanks, Jada.
Thanks,
Keep up
Mr.
the good
Strong.
work. Get caught up on quizzes if you're behind. That'd be a good thing to do.
I'm good now.
Okay, great. We'll see you
Later.